node sequence. So for this problem, we are giving an undirected graph with n nodes numbered from 0 to n minus 1. So in this example, we have the node from 0 to 4 because the number of the nodes is 5, as we can see from the image. So we are giving a 0 indexed integer array scores. So this means for the score 0, for the node 0, the score is 5, and for node 1, the score is 2, and node 2, the score is 9, and for this 3, it's 8, and for the node 4, so the score is going to be score 4. So for the node 4, the score is going to be 4. So we are also giving a 2D integer array as this. So this just means as this, and it is an undirected graph. So from 0 to 1, 1 to 0, 1 to 2, 2 to 1, 2 to 3, and 0 to 2, and 1 to 3, and 2 to 4. So this is an undirected graph. So this is the meaning of the 2D array as this. So a node sequence is valid if it meets the following conditions. So let's just check what's going to be the conditions. Yeah. So the first condition is that there is an edge connecting every pair of adjacent nodes in the sequence. So it must be connected. This is going to be the first condition. So the second condition is that no nodes appears more than once in the sequence. So this means inside the sequence, the node must appear in one time instead of 2 times or 3 times. Yeah. And also we need to take care, the score of a node sequence is defined as the sum of the scores of the nodes in the sequence. It means all the values. So for example, let's just try a sequence. So for example, 0, 1, 2, 3. So 0, 1, 2, 3. This is a sequence, right? Yeah. And we can get a score. So 5 plus 2, 7 plus 9, 16 plus 8, it is 25. Maybe this is the final answer, we are not sure. So we're going to return the maximum score of a valid node sequence with a length of 4. So the length must be 4. If no such sequences, we're going to return a negative 1. So what is the meaning of the length? So the length means the number of the nodes. So it must have exactly 4 nodes. 0, 1, 2, 3, it is 4 nodes. And we can check it inside the example. Yeah. So this 4 just means the number of nodes. Instead of the number of edges, it just means the number of nodes. Yeah, although it said less of 4, it means the number of nodes. As we can see from the example, it is 0, 1, 2, 3. It means we have 4 nodes and it meets the conditions. And yeah, maybe I did some wrong calculation. So 5 plus 2, 7 plus 9. Yeah, why? I did some wrong calculation because this is a 7 plus 9, it is a 16. 16 plus 8 is 24 instead of 25. Yeah, so I just did some wrong calculation, so the final answer is 24. Yeah. And similarly, let's just check the second example. Yeah, because the example means we're gonna have a node which gonna be the number of the nodes gonna be 4. Yeah, but in this example, so for example 0, 3, 5, so 1 is not connected, and 3 cannot be repeated. It cannot be like that. So for example 0 to 3, 3 to 5, so 0 to 3, 3 to 5. Yeah, we cannot go back. So this means the number of nodes is going to be 3. So 5 cannot go to 3 and go to 1. We cannot repeat any of the nodes. So this means there's no such cases, so we're going to return a negative 1. So how can we solve this problem easily? Because the number of the nodes is given. So this means if it is a valid answer, the number of the nodes must be 4. Maybe we can use brute force. Let's just check the number of edges. So the number of the edges is going to be 5 times 10 to the power of 4. So this means maybe we can use the brute force. So the idea is that we're going to enumerate the edge one by one until we find the answer. So for example, let's just enumerate the edge 1, 2. Yeah. If we enumerate the ends 1 to 2, it means this node 1, this node 2 is included. So this node 2 and this node 1 are both included. So this means we only need other two nodes. Maybe this node 4, and for this one, maybe node 0 or maybe 3. Definitely we're gonna choose the maximum. Yeah, so maybe we're gonna choose this 3 and this 4. So what's gonna be the final result? So 2 plus 8, 10, 10 plus 9, 19, plus 4, 23. It's not the maximum. Let's just try to use another example. Maybe we're gonna choose as 1 and 3. Yeah, because we cannot choose duplicate nodes. So this means except 1 and 3, we're gonna check other nodes. So 3 is connected to 2, so we're gonna choose node 2, and 1 cannot choose another 2 because we cannot choose the duplicate. So for this node 1, it's gonna choose a node 0. So 0, 1, 2, 3, we plus them together and we get a score of 24, and we're gonna choose the maximum of 24. Yeah. So this means the problem gonna become unclear. So the idea is that we're gonna use graph. We're gonna enumerate the edges one by one. Yeah. But for each node, yeah. So for example, this for definitely for a graph, we're gonna build a graph, and the graph gonna be a dictionary. So inside of the dictionary, it's gonna be k value pairs, and the k gonna be each of the node. For example, node 0. Yeah, so this is the k, and then we're gonna choose value. So inside the value, actually we're gonna choose a tuple, because we are not only using the node itself, but also we need the value, and the value should be sorted. I will explain why we need to sort the value, but currently let's just put the value inside. So for example, this is node 0. What do I have? What are my neighbor for this node 0? It is 1 and 2. So first of all, I gonna get a tuple. So I'm gonna get the score of 1, it's 2. So first of all, I will get a score, and then I will get a node. So it is a 2, 1. And the next one is gonna be another tuple. For 0, it is a 2. So it means it's gonna be a score of 9. And currently I will not sort it, but later on I will do it. So the score and node 2. Yeah. So every node will be, we will prepare every node will be like that. So this is k, and this is value, and the value gonna be a list. Inside the list, it's gonna be a tuple. And for each tuple, it's gonna be the value of the node and the node, the score of the node and the node itself. So this means if we are choosing this node, this means if we are choosing, so for example, maybe yeah, maybe yeah, this is not maybe, yeah, but definitely we're gonna choose all those nodes as k value pairs, like 0, 1, 2, 3, and 4. Yeah, I will not put everything inside, but basically it will be like that. So for example, if we are choosing ads with 1 and 3, definitely we can get a score. The score index 1, score index 3, we can get a score like 2 plus 8, it's gonna be 10. We can get the score. But what about the others? How can we find this 2 and this 0? So here is this k. Inside this k, there's gonna be an array, and inside of 3, there's gonna be some values. Definitely we're gonna have this node 2. Maybe, yeah, so the score gonna be 9 and 2. This is gonna be a tuple. Yeah, but what about that one? What about 1? Because 1 is also connected. We need to also put 1 inside. Yes, it is. It is inside. Let's just put it inside. We're gonna have a value of 2 with a node 1. Yeah, but which one we need to choose? Because this 1 and 3 already included, we cannot choose 1 or 3. So this one we cannot choose. This means we must choose a 3. So this is okay. If we choose a 3, this means 1, 2, 3 nodes. We still need to have another node. So another node is coming from 0. Yeah, because 1 and 3 is chosen. Another node is connecting to this 1. Yeah. So inside of this 1, there's going to be a tuple. It's going to connect to 0, 2, and 3. So if it connects to 0, the score is going to be 5, 0. And another one is going to connect to 2. So it's going to be 9 and 2. Yeah. And the last one going to be 8 and 3. So the score gonna be 8, and the node gonna be 3. Yeah. So now it comes to, we need to get the conclusion. Which one we gonna choose? Yeah. So for this one, can we choose 3? No, we cannot choose 3 because there's a duplicate. Can we choose 0? Yes, we can choose. Yeah. But can we choose 2? If this 2 is already chosen from this node 3, so definitely for this node 1, we cannot choose this node 2. Instead, we need to choose a node 0. Yeah, so this may be a little bit difficult, but we need to understand how we're gonna solve the problem. Yeah. But definitely we need to solve with the duplicate. So for example, if this node 2 is chosen, and we have to choose this node 2, so for the next, we cannot choose node 2. For this node 1, we cannot choose node 3. We have to choose this node 0. Yeah, but for the values array, what's going to be the maximum length? Is the maximum length 3 is okay, or it should be 2? Yeah, so for this example, yeah, for this node 1, it is connected to node 2, 3, and 0. But how many nodes should we put inside? Can we choose infinite number of nodes inside of the array? No, we just need to choose 3. So for this example, this yeah, let me try to use another color. For this node 1, although it is connected to node 0 to 3, maybe we have the duplicate, but the duplicate, the maximum is going to be 2. So for this 3 and 2, it is duplicate. But what about other one? It is 0. So this means for the maximum length of the array, it must be 3. And for this 0, it is 5. But maybe there's another one. Maybe we're going to have a node 5. But what about the value? If this value is 100, so definitely we're going to choose this node. Yeah, let me just make it better. Yeah, if this is a node 5, so definitely we're going to choose a value. If this value is 100, so definitely we're going to choose this node 5. Yeah, so this means inside of this array, it must be sorted in decreasing order. And we're going to sort this array in decreasing order, and we're going to choose a length of 3. And then, except the duplicate, another value we choose the maximum value. So here, instead of node 0, maybe we're going to choose node 5. Because for the node 5, maybe the value is 100. We need to have this value. Yeah. Now let's just try to solve the problem. I think while you start coding, it's going to be much easier to understand. So we're going to prepare a graph, and we're going to enumerate the edges. For the edges, we're going to prepare key-value pairs, and we're going to append a tuple. So inside of the tuple, the first one going to be the score. So it's going to be the score of this node v, and with this node v. And similarly, another node, because it is a undirected graph. So here going to be score u and this u. Yeah. Let me just print out the graph to explain a little bit. I think we've already understand, but let's just explain a little bit. It is the scores. Yeah. So inside of the score, we can see that in my example, I explained node 0 or node 1. So for this node 1, I have a neighbor 0 with a score of 5, a neighbor 2 with a score of 9, and a neighbor 3 with a score of 8. Yeah, so this is exactly what I need. But I need to sort them in decreasing order, and I only need to choose a length of 3. Because others doesn't matter. I only need to have a length of 3. Even I have a length of 4, 5, it doesn't matter. I only need to choose a length of 3. So except maybe 2 of the values are going to be duplicate, but I need to have another value. Another value must not be a duplicate, but it must be the maximum value. For this node 0, it is 5. So if there's another node, maybe 5, the value is 100, definitely I'm going to choose another node. But currently, this is the only one node I need to choose. Yeah. So the second step is that we're gonna sort the graph with values. So for let's say k maybe a in graph.items. So let's reassign the k value. So graph with the k gonna equal to let's say we're gonna use sorted with this array, and we're gonna reverse it. So reverse gonna equal to true, and we only need to choose a length of 3. So here I'm gonna use a 3. Now let's just check what happens for us. Yeah, so this is what I print out the graph. Let's just use this node 0 and this node 1. So for this node 1, as we can see, it is sorted. The first value, the score is 9. It is the biggest score, and then it is 8, and then it is 5. Yeah. So for this score 9 and 8, it is okay because it is for node 2 and 3. We've already counted. So what about another one? It is node 0 with a value of 5, and this is sorted in increase order, and this is exactly what we need. So we only need to have a length of 3 because this is enough for us to solve the problem. Yeah. Let me just use another example maybe. So for example, if we choose adds of 2 and 4, what's going to happen is that from this node 2, it has neighbors like 1, 0, 3, but we only need to choose one of them. And for this node 4, there's nothing to choose because there's nothing. We cannot choose anything. So in this case, actually, we didn't get anything for this node 2 and 4 because for this node 4, at the right side, there's no neighbors for this node 4. But for 2, we have 3 neighbors. We can choose one of them. But for this node 4, we cannot choose any one of them. This means if we're gonna enumerate 2 and 4, we will not have any value. Definitely, yeah, we cannot update the value. Yeah, now let's just continue the coding. So for the main part of the coding, let's just prepare a final result. As it is said, if we didn't find it, we're gonna return a -1. So this is our final return. And then let's just check the edges. So for UV, inside all the edges, this is just like a brute force. We're gonna use the brute force to enumerate one of the possible results. Yeah. So maybe for score U, yeah, because first one is a score, and then it is the node. Maybe we're gonna use the node A. Yeah. So for score U and this node A in GU, and then we just use brute force for score V, and it node we just use a V. Yeah, because we've already used U and V as the node, so another node may be A, and another node may be B, and inside GV. And from here, we need to check if there's a duplicate node or not. We have to check that. So if U not equal to A, not equal to B, and not equal to V, so we're gonna update the final result. So the result gonna be, yeah, this is score U and score V, and score of U and V. So score U plus score of V, and plus, I think it is the scores. So let me make it right. And then we plus the score U and plus the score V. So this is going to be the final result. Now, let's be careful. Let's be careful about this one, because we need to check the duplicate. Definitely, if we check a duplicate, for example, this is a like add 1 and 3, it is a chosen. Yeah. So for this 1 and 3, it is actually this U and V. So for 1, 3 inside the edges, and we're gonna enumerate GU. GU is for this node, maybe 1. Yeah. So we're gonna check the neighbors. Maybe this neighbor is 0, or maybe it is 2. Yeah. So for this neighbor, it must not equal to. So for example, this is U. U is 1, and V is 3. So this is u, and this is v. So v is 3 and u is 1. And for score a inside GU, so this means 0. This 0 maybe it is 0, maybe a. Yeah, for this variable a, it may be 0, but it is still possible this v can be a because it is its neighbors. So we have to be careful. So this means this v and this a should not be equal instead of u and v, because u instead of u and a, because u and a, they must not equal because its neighbors, the u's neighbors is a. So this means from here it is v instead of u. V not equal to a and b not equal to u. We have to be careful about it. Yeah, let's just use another case. So this is v, right? And for this number 2, maybe this is b, and because this b is v's neighbor. Yeah, so this means the b must not equal to v, and we don't need to check b not equal to v because they are not equal. So this means b must not equal to u, because for v's neighbor, it can be this u. This u it can be a b, or this number 2 it can be a b. Yeah, this is a little bit complicated, but if you try to write the code in one line, it is okay. Or you can write it in several lines. Yeah. Now let me just run it to have a check. Now as you can see, it works. Now let me just submit it. Yeah, as you can see, it passed, and it's pretty fast. And the time complexity is just O(n), because we just use a graph to solve the problem. So this graph is O(n), and from here it is another O(n) solution. N is just the number of edges. For here, we just need to ignore that because this is just constant time. So the difficult part maybe this line. So what about we just write more code to make it clear? So this if tag is that those 4 nodes must not equal. So we can write it like this. So maybe so u and v must not equal. So if u not equal to a and u not equal to b and v not equal to a and v not equal to b and a not equal to b. Yeah, you see, we write a lot of lines of the code. It is not concise, but let's just try. As you can see, it also works. But actually, yeah, actually you see, it works. Yeah, but you see, it's a lot of lines of code. But this may be more clear. Yeah, because we don't want to have the duplicate. U and v must not equal. So this means u should not equal to a. Yeah, because u's neighbor, let's just check, because for this u's neighbor is a, u must not equal to a, so we can just ignore u and a, and we can ignore v and b, because its neighbor is must not equal. So it's going to be like this. So this is more clear maybe. Yeah. Now let me just submit it to check. Yeah, you can write either this code or you can write this code. Both of them is okay, but you have to understand what is the meaning of the problem. It seems it's a really hard problem, but actually it is not that hard if we find how to use the brute force to solve it. I think that's all about it. Thanks for watching. See you next time.